Okay, so we're going to be learning now the core section of this unit, which is relating what you know about slope, rise over run, and similar triangles. I'm going to be solving page 7 from your workbook, and this is page 8 and page 9. They are very similar, okay? And the format is friendly, so you can type in and give me your answers. So let's go and then start with your page 7. It says similarity and slope. We will now connect our knowledge of similar triangles to the concept of slope. First, we will establish that triangle ABD is similar to triangle DCE in the diagram on the right. Okay, so these two triangles are similar, and we can tell that this angle and this angle are the same because they are right angles, and also this line in here will be a transversal and another, parallel lines, and these will be your transversal. So this angle and this angle are corresponding angles. So by angle criterion, these two triangles are similar. Okay. The next section says, why is BD parallel to CE? Well, this line and this line are parallel because they are horizontal lines. Those are the lines that we create, and we make sure that they are horizontal. That's why they are parallel. Okay, so write with your own words every single time you ask you why they're parallel. That's an information that is technically given. Now, we have angle ABD is congruent to blank. So let's go here and say, well, angle ABD would be this angle in here. It is congruent to which angle? So it is congruent to this angle in here because they are both right angles, and right angles are congruent. You know they are right angles because you are making them right angles. You are making horizontal and vertical lines, and vertical and horizontal lines make perpendicular angles. So make sure that you explain that on your section of the workbook. Then we have angle BAD is congruent to blank. If I look at BAD, BAD is this angle in here, and we already said that these two lines are parallel lines, and therefore this line in here, it is a transversal. And if you remember your positions, they are half the same position, and this is another transversal right here. So they have the same position on your lines. Okay? Here you go. That looks better. Okay? I was picking the wrong parallel lines. So we're gonna say here that, okay, DCA, remember that the order matters, and then BAD, it is congruent to CDE, and make sure that you explain that because they are both corresponding angles, they are congruent. And then we have that and triangle ABD is similar to triangle DCE. Remember, the order matters, so congruent vertices, D, C, and then the last one. Why? Because we have proved by the angle criterion these two triangles are similar. Okay, because we proved that these two are congruent, therefore the triangles are similar by angle criterion, which is the lesson from last class. Mark congruent angles for triangle ABD and DCE on the diagram. So we're gonna go here, and then the only thing that I need to mark as congruent will be the other angle in here. So let's say 2 green lines. Done. Question 6 says, in similar triangles, corresponding side length are similar, proportional, therefore the values of the ratios of corresponding legs, so the ratios that we're going to calculate, they should be congruent. And then we're going to prove that now. Find the values of the ratios of corresponding legs within the similar triangles. So we're going to take AB, so what is the length of AB? 2 units over the length of BD. So we're going to go back up and then let's see 1, 2, 3, 4. 2 over 4. We can simplify this fraction and then say that this is the same thing as 1 over 2. How do I simplify a fraction? Greatest common factor is 2. You divide by 2, denominator and numerator, and you get 1 over 2. And then let's do the same thing with the ratio between CD and DE. So let's go up and then measure how much is CD. It is 1, 2, 3, and 4. And then CE is 1, 2, 3, 4, 5, 6, 7, 8. So we're going to write in here 4 over 8. I can simplify this fraction by dividing by 2, by 4, actually. And this is 1 over 2. What do you notice? It says here, find... it's not asking you yet, but what do you notice about these ratios? They are the same, they are congruent, and that's what is expected. Because if we have the same slope on the same line, then it doesn't matter which triangle you make on that line, you're going to get the same value, the same ratio. Find the equation of AE in slope-intercept form. So if you remember, slope-intercept form is y equals mx plus b, where the letter m stands for slope and the letter b would be your y-intercept. So let's do here y equals mx plus b on this graph. I'm just gonna clean this up a little bit. Okay, so I'm gonna pick 2 other points just to show you that you don't have to use these AD, DE. I'm gonna pick this point in here with this point in here, and I'm gonna find my slope. The slope is rise over run. I'm rising 1, and then I'm running 2. Both of them are positive, so my slope equals 1 over 2. And the next thing that I need is my y-intercept. So I'm going to check where my line cuts the vertical line, which is the y-axis, and it's cutting the y-axis at positive 3. So if I need to write down my slope-intercept form, my equation, it's going to be y equals 1/2 of x plus 3. And these are the values that we found: the slope, rise over run, the place where your line cuts the y-axis. How are the results from problem 7 and 8 related? I skip a part in here. It says circle the slope in your equation. So how are my slope and the ratios of the legs related? They are related because they are the same number. The ratio that you find when you divide the leg over, like the height over the base of that triangle, when you divide the legs, it is the same value of doing rise over run. How many units you're rising and how many units you're running. So you're finding the slope when you're finding the ratio of the legs. That's why you can compare and say, hey, these are the same. It doesn't matter if the triangles are similar. When you divide these numbers, you're always going to get the same value because you're always finding technically the slope of those points. If you have right triangles, of course. And that's it for this week. Let me know if you have any questions. Make sure that you check with Mr. Jennings or with me. Feel free to, if you have a question specific section, remember that you can always comment, and then when you're typing here, whatever, you add plus, and then you can add the teacher, and then we can go directly to your section and answer your questions. Problem 9, it's a little bit different, and you have to be careful when you do your rise over run because this slope is negative. So that's it for the week. Let me know if you have questions.